So far, we have covered the area of data wrangling or reshaping data, which is an essential part of the whole data preparation part of data science. Now we will turn to the topic of data manipulation, which is another important aspect of the data preparation step, but somehow different to the data wrangling part, because remember that we encountered two functions, pivot-longer, pivot-wider from the tidyr package, and both of them didn't change the content of a data frame, but they only changed the shape. The difference from data manipulation to reshaping is that the operations that we're about to learn right now are actually changing the information contained in the data set itself. That's where the name data manipulation comes from. In this video, we will cover the three most basic aspects of data manipulation, or data set manipulation to be more precise. Namely, we will learn how to filter rows, how to select columns, and how to create and manipulate certain variables or columns. To this end, we start with the dataset data raw long, which you can directly read in from the course material. And the first thing we want to do is we want to filter this dataset. So we want to basically reduce the number of rows. And there are a couple of ways of how we can think we could do it. Let's, for instance, only keep those rows that contain information about the situation in Germany. So we want to filter that dataset data raw long based on a certain logical condition, namely that the variable country equals the string Germany. That is always the basic idea when you filter rows. You need to think of a certain logical condition that it can only be fulfilled for a subset of the rows in this data set. So to filter the data, we will use the function from the package dplyr called filter. The first argument to filter is always the data set we want to work with. So in our case, it's data raw long. The second, third, or whatever argument is always the logical condition or the logical conditions that need to be fulfilled. So in our case, the logical condition is that country should equal Germany. If you are not familiar anymore with these logical operations like equals, or bigger, smaller, etc., you should recap that, because that is absolutely essential in the context of data manipulation. But if you remember, to understand this line of code is pretty straightforward for you, because that's a logical test whether the variable country equals Germany. And if we execute this line of code, we see that our data set gets reduced and only the columns for which the logical condition country equals Germany yields true. So to see this here, to simulate the first row, here country equals to Germany, and the logical test we implemented here, Germany equals Germany, obviously leads to true. For line 5, however, the content or the value of country is Greece, and Greece equals Germany, obviously yields the result false, which is why the line 5 is not part of the filtered data set, nor is line 6, 7, 8, etc. You can, of course, combine as many logical tests as you wish. You just separate them by a comma. So imagine that we only want to keep those observations for Germany for the year 2018. So in this case, we could say, okay, the variable year should equal 2018. If we effectuate this, we only keep 2 rows. Here, we do not necessarily need to use the equality operator. We could also say, for example, the year must be bigger or equal to 2018. The result will be the same, And as you can imagine, you can add as many logical tests to filter as you wish. If you've seen already the video on pipes, you will immediately understand that we can rewrite this code as well as this. And this is a practice that many people follow, namely to use filter always in conjunction with a pipe. The pipe here takes dataset raw, throws it into the next line, and then applies the function filter to it. That also makes it easier to understand of how the final result comes about. And of course, if we want to proceed with the filtered dataset, we must give it a name. So here we could say like data filtered, use the assignment operator, and we now have our filtered data set that we can then process further. Now, why the function filter is used to reduce the number of rows in a data set. We might also want to reduce the number of columns in a data set, and this is exactly what the function select is used for. So just as a recap, this was our original data set. We filtered this data set using the function filter from the package dplyr, and we reduced the number of rows. Now imagine, since this data set only contains one country, we could also remove this column country entirely. And to do so, we could use the function dplyr select. It works very similar than the function filter. So what I'm going to do is I immediately use the pipe version here. So I start with the data set I want to work on. I add the pipe, and then I use dplyr select. The first argument of select is again the name of the data set I apply the function to. This first argument is set implicitly here because I've used the pipe in line 72. And I can now immediately start with the second argument. And the second argument to select is actually maybe more than one argument, in the sense that I can now write down the names of the columns that I want to keep or remove from the data set. Now, the easiest way to do, the most straightforward way to use it is probably to just type the names of the columns I want to keep. So in this case, it might be year, variable, and value. Note that I did not write the name of the columns in quotes, so I'm not writing them as strings, I just write the names down. If I execute this, you see that only those columns are kept in the resulting data set. While this works, I recommend you not to do it, but to familiarize yourself immediately with an alternative way of using this function, namely by providing the names of the columns you want to keep as character strings. You see, the result is exactly the same. Note that we used the function C to concatenate here the names of the columns that we want to keep. And if we pass this as an argument to select, we can basically select the columns like this. If you use a minus sign here, you can also deselect columns. So if we execute this kind of code, it deselects all the columns, meaning that it only keeps the column that is not mentioned. In this case, it's the column country. So depending on whether you want to keep more columns or you want to remove more columns, either using the minus notation or the normal notation might be more beneficial for you. Now you might ask yourself, why do I recommend you to use this style using character strings? Well, first of all, I think it's a little bit less error prone because names without quotation marks are usually used to refer to objects, functions, etc. So I think this way here of writing is a little bit more consistent with the overall syntax of R. It's more easy to understand. But secondly, it's also more flexible because it's more consistent with the way of using so-called selection helpers. There's a specific video on selection helpers that you can watch and that I can highly recommend. That I would highly recommend to you. The idea of selection helpers is here that they can be used to select columns based on certain rules. Just to give you an example of how such selection helper could look like, one selection helper is called starts with. We could say, okay, we want to keep all the variables that start with V. If we execute this, you see that automatically all the variables with V are selected. So these selection helpers are quite useful if you want to select a wide variety of columns, but there's a separate video that you can have a look if you want to. It's not necessary, it's optional, but as you see, they can save you a lot of work. Another situation where the selection helpers are very useful is if you want to take this vector of column names here and define it elsewhere. So you could, for example, think of defining a variable called calls to keep. So we have here a vector containing names of columns in this data set here. And you can then pass these this vector to the select function. However, here you need to actually use the selection helpers explicitly. One of the selection helpers is all of, and that basically means all of the columns mentioned in this vector should be selected. So this all of is one of these selection helpers. If you want to learn more about them, look at the optional video. For now, just keep in mind that in case you want to define the columns to keep or the columns to remove in a separate vector, you need to use this function all of, or there is another one that's very similar, any of, which apparently does the same thing, but I leave it to you to check out what's the difference between all of and any of. Anyway, you need to use these kind of selection helpers if you want to define the names of the columns to keep or to unselect outside the function call as such. And as above, you need to obviously define a name or select a name for your data set if you actually want to use it further. Otherwise, dplyr select only creates the data set and shows it to you in the console. Now we come to the next part, or the next routine that we frequently use in the context of data preparation, namely the routine of creating or manipulating variables. To this sense, let's look at this raw data set that you've encountered in the very beginning. It was this one here, where we see the dynamics of unemployment GDP for Greece and Germany over the years 2017 and 2018. Now imagine the situation where you want to create a new variable, which we might call difference, that corresponds to the difference in unemployment and GDP between 2017 and 2018. To do this, we can use the function from the package dplyr called mutate. Now, the name of this function is maybe a little bit irritating in the sense that you use the function mutate both for creating new variables out of existing ones or by mutating existing variables. It's basically the same thing. You use mutate the same way as you use the select function or the filter function, first argument always being the data set on which you operate. As I said, I like this notation using the pipes where I say, okay, this is the data set I start with. I throw it into the next line by the pipe. So it implicitly is the first argument passed to mutate. So now I can start with the second argument of mutate. And the second argument of mutate is not an argument in the traditional sense, but it's an operation, namely the operation of creating a new variable. So if you want to create a new variable, you first need to write the name you want to give to this new variable. So in our case, let's call this new variable difference, because we want to compute the difference between 2017 and 2018. And let's say we call it different apps, because we want to create the absolute difference by just subtracting the value from 2017 from the value in 2018. So we then write the equality sign, meaning that the new variable different apps should be equal to, and then we write the mathematical operation that should underlie the creation of the new variable. So in this case, it's the name of the column 2018 minus 2017. Now here's something very important, because we are dealing with a special case here that is very typical. If you execute this code as it is right now, it works in the sense that a new column is created, different apps. So when we look at it like this, it's more clearly visible. And this new column that has been created by dplyr mutate has the name as we've specified before the equality sign, and it contains the result of the operation that we've written here on the right. Now you might wonder then, why is 1 here? Because 3.38 minus 3.75 is not equal to 1. As I said, we are dealing with a certain special case here, because the name of the columns here correspond to numbers. This is something that you should always avoid, because it creates ambiguous results. However, these kind of data sets here are very, very typical. So we find them quite frequently where the names of columns correspond to numbers. So we need to tell R that we are not want to create a new column that corresponds to the difference between 2018 and 2017, which obviously is always 1, but that we want to create a new column that corresponds to the difference between the column called 2018 and the column called 2017. In order to do so, we need to use these special quotes here that we need to wrap around the column names. If we execute the code now see that we have the new column exactly as we would have expected, namely by corresponding to the difference between 2018 and 2017. Of course, we might want to save the new data set, because we want to process it further. And one way of processing it further could be to manipulate an existing variable. As I said, we do this also with the function mutate. We could add a new line, again with the call dplyr mutate, and we can manipulate an existing variable by using exactly the same syntax as here, but by writing on the left side a variable that is already existing. So in our case, we might want to take the difference, or the variable that we just created, different apps, and we want to say divide it by 100. If we execute this code and look at the result, we see that the second call to dplyr mutate has not created a new variable, but it has altered the existing variable different apps. So that's what I said. The name of the function mutate is a little bit irritating in the sense that it's used both for creating new variables or for mutating existing ones. This is just something you need to keep in mind. Also, you should keep in mind that there are basically 2 ways you can chain operations in mutate. One thing is you make really different calls of the function mutate, but you could also separate the different operations just by a comma. So let's keep it like this. Equivalently, we could write here, could take this operation and just add a comma here And if we execute it like this, exactly the same thing happens. So you can, if you want to mutate more than one variable or create more than one variable, you can wrap all this within one single call of the function dplyr mutate. Important thing to keep in mind whenever you want to do an operation with with columns that have names that are non-standard, for instance, in the sense that they are not characters correspond to strings, but to numbers, you should make sure that you use these special quotation marks to indicate to R that you're talking about the column names here and not about the numbers. But aside from this, use of mutate should be straightforward, at least if you want to apply it to single columns or to all the rows in the data set as we just did.